Welcome, as together we explore the wonderful world of orchids and delve into the intriguing relationship between the color of light and plant growth. I am Ross Cavanagh, and joining me are my fellow researchers, Charli Baker, Paige Hurrey, and Cody Maguire. Conjointly, we shall unveil the results of our experiment, our predictions about how plants will respond to different wavelengths of light, and the challenges we have encountered performing this task.
Plants are the masters of converting sunlight into energy, but they have their preferences. Chlorophyll is the green pigment contained in all plants that captures the radiant energy of sunlight and converts it into the fuel that drives plant growth, carbohydrates. But what happens when we change the colors that they are exposed to?
But before we dive into the experiment, what is the science behind it? Light comes in a spectrum of colors, each with a unique wavelength and frequency, and plants have evolved to absorb certain colors more effectively than others. For this experiment, we'll be focusing on two specific wavelengths of light, yellow and green.
Yellow light with a medium wavelength and frequency has little good effect on plants, as it does not support the plant's production of chlorophyll and inhibits the production of carbohydrates that the plant needs to grow and thrive. Similarly, green prevents photosynthesis, as the famously green leaves of most plants absorb all wavelengths of light except for the green which they reflect due to the green chlorophyll pigments.
So our journey begins with the question, how does the color of light impact the percentage change in biomass of Dendrobium Discolour Broomfieldii, a species of orchid? We hypothesize that, despite the unfavorable conditions of both green and yellow light, the green light will be worse for the orchids due to the aforementioned effects of green light on chlorophyll outweighing the negative effects of yellow light.
To test our hypothesis, we have designed an experiment that should allow us to fairly test the impacts of yellow and green light on these orchid plants. We were able to manipulate the variable of light color by wrapping clear plastic containers in respectively colored cellophane and attaching it by masking tape. The orchids were then placed into individual test tubes with a fertilizer solution and a piece of filter paper. Then another container of the same color was placed upside down on top of it and attached with more tape to ensure that the orchids would only be exposed to light of one color.
Before the experiment, the orchids were weighed to find their initial biomass. They were then exposed to their respective light colors for 1 week before being weighed again to find their biomass after the experiment. We used these weights to find the change in biomass for each orchid, then calculated the percent change in biomass.
Using this data, we then performed a data analysis test, only to find that the experiment did not support our hypotheses, as the orchids that were exposed to green light exhibited positive growth with an average percentage change in biomass of approximately 7.12%, while the orchids under yellow light suffered a decrease with an average percent change of around negative 19.26%.
Yet, no scientific journey is without its challenges. As the p-value from the data analysis test shows, there is an increased likelihood that these results could have occurred at random without any change in variables. This could have been caused by a number of limiting factors in our experiment and the data, such as human error in measuring, the time frame the experiment was completed over, and the amount of water given to the plants, affecting how they grow, rather than the color of the light, being the primary determining factor in the growth of the plants.
We have hypothesized that yellow light will be better for the growth of orchids than green light. However, our experiment revealed that green light may be more nurturing. These results and the data analysis contradict our research and show the need for more expanded and uninhibited research to find the ideal light color for plant growth.